Hey everybody, I am here to start a new unit with you. We are about to dive into inequalities, but before we can solve any inequalities or do any word problems or anything crazy like that, we need to know how to graph them. All right, so we're going to talk about the difference between the solution for an equation and the solution or solutions for an inequality. So hopefully you've just finished solving equations. And every time in 8th grade that you solve an equation, you get one solution. I'm going to write in a different color today because we're going to do lots of graphing on the number line and I don't want to use the black ink. So if I wanted to show you the solution to an equation on a number line, I could. I would just put 1 point on the number line. Let's say I solved an equation and I got x equals 1 as my answer, and I wanted to put it on a number line. I would just put a dot on 1 and call it a day. That's it. That's all I would have to do. But with an inequality, it's not the same. So inequalities do not just have one solution. In fact, they have infinite solutions. Like the infinity symbol. That means they have an endless number of solutions. There is no stop. It's kind of like the digits of pi. They go on for infinity, so do the solutions for an inequality. So if I look at this first one, let's look at it. It says represent x is less than 1 on the number line. And I'm going to write less than so that I remember what that is. We've talked about that in previous videos, but I'm just going to write it down. If I wanted to give you solutions for x is less than 1, I could list any number that was less than 1. 0, -1, -1.5, -1.6, -1.65, -2. See how that could go forever and it could get really obnoxious? That's what we mean when we say infinite solutions. We mean x is not equal to 1. X is literally any number you can think of less than 1. So what does that look like on a number line? Well, my inequality doesn't say that it's equal to 1. So I am going to put a dot on 1, but I'm not going to shade that dot in. I'm going to leave it empty. And that just means, hey, it's going to be near 1, but it's not including 1. Okay, and then I want to indicate that it can be any number less than 1. If you see the direction that that's pointing, I'm actually going to turn that into an arrow, and I'm going to move that arrow down here onto the number line, and that's how I'm going to show my solution set. And that probably looks familiar to a lot of people, but I'm talking about every number less than 1. So I'm going to point my arrow towards those numbers that are less than 1. And I could give any of those as solutions. I could say 0 is a solution because 0 is less than 1. I could say -3 is a solution. See how that arrow is eventually going to go to -3? That's because it's less than 1. I could even say -416 is a solution. Because if I drew my number line longer and I drew that arrow longer, it would eventually get to -416. I just can't say that it's any number greater than 1, and I can't say that it's equal to 1 either. It just has to be less than 1. Now the next one is going to be the opposite. So this says represent x is greater than 1. So I'm going to write down greater than so we don't forget what we're doing while we do this problem. But it doesn't say x is equal to 1. So I'm going to do the same thing I did on the other one. I'm going to put a circle there, but I'm not going to fill it in. Meaning, yeah, it can get really close to 1, but it doesn't include 1. Like 1.1 is fine, 1.2 is fine, but not 1. So I'm going to skip around it. And then this time, since this is a greater than symbol, I'm going to want my arrow to go the other direction to indicate that my solutions are all going to the right. They're all bigger or greater than positive 1. So 5 could be a solution. Let's go back and let's say 1.1 can be a solution because that's greater than 1, right? And you could, of course, include some huge numbers. I'll just do 92. Because if I kept drawing that number line and I kept drawing that arrow, it would eventually get to 92. And you are welcome to put different solutions on yours if you want. Help yourself. Let's look at these last 2 graphing examples, and they probably look really familiar, but there's one little thing that's different on both of these. Both of these inequality symbols have a little line under them, which means x is any number in the world less than or equal to 1. In fact, I'm going to write that out really quick. Boom. X is less than or equal to positive 1. So since it can be equal to 1, when I make my circle this time, I'm going to go ahead and fill it in. Like I did for the equation one, I'm going to fill that in. And then I'm going to draw my arrow going to the left. And you can make it as long or as short as you want, as long as it's going in the correct direction. And then when I give my 3 possible solutions, I can include any number that is less than 1, but this time I can also include 1 as a solution. So I'm going to say 1 is a solution, -3 is a solution, and -100. Those are all solutions to this inequality. But there are infinite possible answers. Now the other one is going to be the opposite. So let me pause and write that down real quick. This one is greater than or equal to. So since it has the equal to, I'm going to put my dot on 1 and fill it in just like I did for the equation. And then I'm going to draw my arrow going to the right. As long or as short as I want it to. It's really not a big deal. And for my 3 possible solutions, let's say 4 is a solution, 12 is a solution, and then somebody in class always likes to say something like 1 million. So I'm going to say 1 million is a solution. But all of those numbers are greater than or equal to 1. Oh, darn, I should have also said 1. It's kind of the whole point here. I got so distracted by writing a million, I forgot the obvious answer. It can be any number greater than 1 and including 1, but there are infinite possible solutions that you could put there. And that is how you graph the solution to an equation or to an inequality.